Okay, so these should mostly be review for you. It should not be new. A point is a location in space, has no size and no shape. So here's an example of a point. And then it has a name next to it. So in this particular case, we have point A. So we name it with that capital letter A. A line is made up of points. So for example, here's a line made up of points. It goes infinitely in both directions, right? Cannot be measured. So I have a point, multiple points, right, on this line. So let's say I have point A, B, and C on this line. To name it, I can just use any 2 points on the line. So for example, I could say AC. So this would be line AC. Or I can go backwards and say CA. Or let's say you're like, hey, you know what? Any 2 points, so why not AB or BA, right? Notice that I know it's a line because it has arrows in both directions. When I name my line, I make sure to draw a line on top of the 2 points. The other way we can name a line is if we have like a cursive lowercase letter, like let's say L over here, then I could also name this line L. Alright, this L, by the way, is not a point on the line. It is just a name. Alright, all the other things we used to name it, there were points on the line. Next, a line segment. Line segment has 2 distinct endpoints. Even if we have a point in the middle, if I want to like name this entire line segment, then I use my 2 endpoints. You can measure this line segment. You could take a ruler and measure it, but the line itself right here, we can't measure it because it goes infinitely in both directions. You can't measure infinity. So this line segment goes from A to B, so I can name it, goes from A to C, so I can name it line segment AC. So if I say line segment, what I draw on top of it does not have any arrows. It's just a bar. I can also go backwards and say, hey, that line segment CA. Same thing as line segment AC. Array has 1 endpoint and then goes infinitely in the other direction. I could have drawn array the other way. This time I just decided to draw one here. So endpoint and then goes to infinity. And then since it's going to infinity, there's going to be points along the array. So here I have my points. Alright, so to name it, I always have to start with the endpoint. Next, I pick any of the points that are going in the direction to infinity. So I can go ahead and say AB. This is ray AB. Alright? And then on top of it, I draw a ray. And you might be like, why is the arrow not pointing in this way? No, when we name a ray, our arrow is always pointing this way. Even though in my picture right here, my ray is pointing this way. Okay? So, ray AB goes like that. Or I could also say ray AC because I want to show you real quick. If I say, hey, A, B to infinity, eventually it'll hit point C and any other point that's there. So I can say starting from A to B infinity, or starting from A, C infinity. Or I can say starting from A to, if there's other points, use any of the other points. The main important thing is A has to be included because that's an endpoint. Okay? And then don't forget to draw your ray on top. Collinear means that points that are on the same line. So for example, if we have a line, A and B, for example, are collinear. C is hanging out over here. C is not collinear. It is non-collinear. So in this particular case, points A and B is an example of collinear. A plane, flat surface made up of 3 non-collinear points. So let's see if I have these 2 points collinear because I can draw a line through them. All 3 not collinear because I can't draw a line through all 3. You know, I can only draw a line this way, or this way. I can't include all 3 on the same line. So here's my points. Here's my plane, that's the flat surface. So to name this plane, I can call it plane ABC. I use 3 non-collinear points to name the plane. Have to be 3 non-collinear points. The other way that I can name this plane is if I have a cursive letter. Let's pretend we have a cursive R right here. Then that R is not a point. Instead, it's just a cursive letter. It's just a name. So I could say plane R. Okay, so in our takeaways, let's go ahead and say, hey, name of a plane. You have to use the non-collinear points. If I have, like, let's say I have a point D here that happens to be on the same line right here, I could not say plane ABD, okay? Or plane ADB. That D is on the same line as A and B. I have to use A, B, C, or I could say D, B, C, right? Our plane has to include this C somewhere, 3 letters, okay? All right, coplanar means that it's all on the same plane. So in this case, let's say I have a line, I have a point A, I have a point B. Let's say I have a point D out here. Okay, so since a plane goes on infinitely in this direction and a line goes on infinitely in this direction, A and B are all on that plane. Even though it doesn't look like it, but a plane is a flat surface, it goes on infinitely in this direction. But D is below the plane, so D is not on that plane. So points A and B, coplanar. Line AB, coplanar, right? But not point D. All right, intersection where 2 objects meet. So for example, I have 2 lines right here. Those 2 lines, they meet right here. This is my intersection. Okay. Moving on, let's practice this. 2 sets of collinear points could be P, R, and, well, let's see, collinear, all 3 have to be on the same line, so P, R, and Q are on the same line. N, R, and M are all on the same line. Name a line that is coplanar with line MR. Well, let's see. MR is here. I don't see any other line drawn. However, we can draw a line through any 2 points. So I can draw a line through B and M, and that line will be on the same plane. So go ahead, BM, line. And you're like, there is no line. There can be. We can make a line. Whoops. Any 2 points can make a line. 2 or more. All right. Name the intersection of PM and MN. Well, notice that PM and MN both have the letter M in common. So that means they meet at point M. And you might be like, PM, where is that? Well, we can create it. Oops. here you go. We can create it. PM and MN, they both meet at point M, right? Okay. Name the intersection of plane A and PQ. Well, let's see. PQ is right here, and the plane's right here. They meet at point R. Give another name for plane A. 3 non-collinear points right here. They all have to be on the plane, these 3 non-collinear points. So let's see. M, R, and N are all on the same line, so I can't use all 3, but I can use 2 of those. So I can say plane M, R, so I can use these 2. And then the third point has to be something that's not on the line, so I'm going to go ahead and use that B. There we go. All right, now, the wrong answer would have been using point Q or point P, because those aren't even on the plane. Okay? Name the intersection of PQ and MN. So let's see, we have MN here, we have PQ here, they meet at point R. What's another name for ray MN? Well, ray MN starts at M, goes to infinity, let's see, in the N direction. So I could also use MR, because it's going to infinity in the N direction, so I could say MR. All right, when we write the measure of a segment, then we can go ahead and write that segment without a bar on top to say, hey, that means measure of segment. So if I, for example, if I say, hey, xy is equal to 5, that means that segment xy, the measure of it, the length of it is 5. All right? I will not say xy segment like this is equal to 5. Segment xy like this, we're talking about the whole shape itself. We're not talking about measure. All right, for measure, no bar. Okay? So we're not doing it that way. All right, next, segment addition. Segment addition means that, like, my segment right here, notice that it's got this part and this part. Segment addition means that I can take these 2 parts, add them together to create this whole segment that we see. It's kind of self-explanatory. We see the way it is. So the way it works out is QR, which is this part right here, plus RS, this part right here, is equal to QS, this whole segment here. So if I had to solve for that question mark, I could say, hey, from Q to R, that's 14, plus this part right here, that's question mark, is equal to 60. Now to get question mark by itself, I just move my 14 to the other side. And my question mark in this case is equal to 46. Okay. All right, next. Mathematical proof. A proof is kind of something that you, oops, never mind, we have another example. All right, points A, B, and C are collinear. So I'm going to draw a line. I'm going to put my A, B, and C on the line. It says point B is between A and C. Good, I have my B in the right place. AB is 8. BC is 4. Find AC. Well, for AC, I'm just going from here to here, right? So 8 plus 4 equals this thing right here, right? So AB plus BC equals AC. 8 plus 4 equals what we're solving for. 12 is that length of AC. Or actually, I could have just kept this as AC. Either way, we can just call it AC rather than question mark. There we go. AC equals 12. All right, next, proof. A mathematical proof is like a logical argument where you're listing out every single step on how you got from from one thing to your conclusion, every single step, and every single step has to have a reason that's either a definition, a postulate, or a theorem. So right here, these are all properties. So we can use a property, a definition, a theorem, a postulate for each of our reasons that we're doing something. So for example, if you take this problem and you want to solve it, you might be like, the first thing I want to do is combine these like terms. So you're going to go ahead and combine the terms, and you're going to be like, 3x plus 2x, that's 5x. And then you keep the rest the same, and you're going to say what I did is combine like terms. Next, to solve this, you would want to move this 5 to the other side. To move it, you would add 5 to both sides. What did I do? What is that? Well, add 5 to both sides. That is my addition property of equality. So over here, my reason that I'm going to give for how I got from here to here, addition property of equality. Notice that each one of these reasons is talking about the step you took right here to get to this next step over here. So once I see the equation like this, my next step that I would take is I would divide by 5 on both sides. So divide by 5 on both sides, I get x equals 5. I use my division property of equality. And now the last thing you have to do is you want to make sure that what you have in your last box here is actually what you were trying to prove right here. It has to match. If it looks any different, then you have to keep going and do something else. All these are the proof terms that you're going to use on this side, on your reason side. So, looking at our proof over here. Since the box is already filled in, we have to figure out what did the person do to get from this step to this step. If I were to solve, well, let's see, I see that they don't have parentheses. How did they get rid of the parentheses? Well, they multiplied by 2 over here. That's called the distributive property. So we're going to do distributive property. And you can shorten it, right? Just don't say dp because there's division property. You shorten it, but like in a way that's understandable. So they distributed the 2, now we're over here. Now we have to figure out how did the person get from here to here? Well, let's see, the 2 is missing. What did they do with that 2? They moved the 2 to the other side by subtracting 2 on both sides. So that is subtraction property. And you could say subtraction property like that, or subtraction property of equality. Either way works. Okay? All right, next. How do you get x by itself? What do you do next? Well, what did this person do to get from here to here? They divided by 2 on both sides. Division property. Okay. All right, moving on to this one. Oh, last thing. Make sure that this is the same thing as this. If it looks different in any kind of way, then you have to go, you have more steps to do. Okay? All right, moving on over here. The first step is always what's given to you. So notice up here, this was given to us, so given. All right, next. What looks different from here to here? Well, I noticed that this 3x is not there. I also noticed that this 4x is now just x. What did they do? Well, they moved this 3x to the other side. How do you move it? You subtract 3x from both sides, right? So we use subtraction property. All right, or you can say property of equality or just property, either way, right? You can shorten it. Okay, next, we have to look, how did this person go from here to here? What's different? Well, this -8 is changed to a 2. How did that happen? Well, this 10 is missing from this side. from this side over here. So it looks like they moved their 10 to the other side. So how do I move my 10 to the other side? Well, I'm going to add 10 to both sides. And now I have addition property. Oops. -8 plus 10 is 2, so that's good. That's how we got from there to there. All right. Last step. What's this? 2 equals x. That's not this. So I need to flip it. So I need to go back to my paper that has all the terms defined and see, like, what is it called when you flip it. So over here, all my things defined. Right here, symmetric property is when you're flipping something. A equals B becomes B equals A. It's the same exact thing, we just flipped it. So that is symmetric property. All right, next. So the first thing that I'm going to do is put all of this stuff in my given section. So I'm going to say, hey, put all this stuff here, and I'm going to go ahead and say that was given to me. Okay, next, what did they do? Well, y equals 1, instead of a y, they put the 1 there. Well, what are you doing? What is that called when you're putting the number in where the letter was? That's called substitution. So we did substitution property. Okay. All right, next. The 1 disappeared. Why? Well, they combined like terms, right? 2 times 1 is just simplified, or combined like terms. And instead of writing out combined like terms, that's written over here, combine like terms or simplify, I can just write CLT. I can shorten it, right? All right, last thing, how would you get x by itself? Well, what I would do is I would subtract by 2 on both sides, and that's exactly what they did. If you subtract by 2 on both sides, then you get 3 by itself, so subtraction property. And we just check, does this look exactly the same as this? It does, so we're good to go. Last one. All right, on this last proof, it's all blank, which means nobody's telling me what steps I have to do. I get to decide. So first thing I'm going to do is write down my equation. And I'm going to write it exactly the way I see. Oh, plus 2x right there. And then I'm going to say that was given to me. And since this is all blank, and I get to decide, what I'm going to do is I'm going to solve the problem over on this side, and then I can go back and say, hey, what are the steps that I took? So if I were to solve this, write out my equation again. All right, the first thing that I would want to do is I would want to go ahead and combine these two, right? So I would say 3x minus 4 is equal to -3 plus 2, that's a -1. All right, so what did I do here? I combined like terms. So I'm going to say combine like terms, and what I end up with is there. So 3x minus 4 equals -x plus 8. All right, now I have a lot of options for what to do next. I want to pick a side for my x's and pick a side for my numbers. For my x's, I'm going to go ahead and pick this side, which means I want to move this x over here. So I'm going to add x to both sides. So that is addition property. And what I end up with, 3x plus x is 4x minus 4. The rest carries, right? So we have 4x minus 4 equals, this cancels out, equals 8, right? Okay, so next thing what I would do to get this x by itself is I would want to move this 4 to the other side. So to move it, I would add 4 to both sides. So I'm doing addition property again. This cancels out. We get 4x is equal to 12. So over here, I would write 4x equals 12. All right, last step, what I would do is I would divide by 12 on both sides. No, sorry, divide by 4 on both sides. So divide by 4 on both sides, that's division property. So I end up with x equals 3. So x equals 3. Is this the same thing as this? Yes, it is. So we are done.